Given that f of x is equal to 4x squared all over 1 plus x squared, find the square root of f prime of 2. The function f of x is a quotient of two functions, 4x squared and 1 plus x squared. For us to easily perform this differentiation, we are going to make use of the quotient rule. And the quotient rule states that if we have our function f of x equal to u of x all over v of x, a quotient of two functions, then the f of x all over the x will simply be equal to, we are going to apply the quotient rule. We take v of x, the function v of x, times the derivative of u of x with respect to x minus the product of the function u of x and the derivative of the function v of x with respect to x, and we divide all this by the function v of x all that squared. This is the quotient rule. We have our function f of x equal to 4x squared all over 1 plus x squared. This is the same as this equation function u of x on v of x. Let's say it is identical to this. Then u of x is the numerator, which is 4x squared, and v of x is the denominator, which is 1 plus x squared. We know u of x and we know v of x. Now let's find their derivatives with respect to x. U of x is equal to 4x squared. Then the u of x over the x will simply be equal to, we have to differentiate this function. We're going to take the power. 2 times 4 gives 8 times x raised to the power 2 minus 1 gives us 1. And x raised to the power 1 is the same as x. This will give us 8x. V of x is equal to 1 plus x squared. Then the v of x over the x will simply be equal to, the derivative of the constant 1 is 0 because 1 is independent of x, plus the derivative of x squared, which gives us 2x raised to the power 2 minus 1, which is 1, gives us 2x. Now we can proceed to find the f of x on the x, and this will simply be equal to, we are going to make use of the formula for the quotient rule. This will give us v times du on the x minus u of x times dv on the x all over v of x squared. This will be equal to, our v of x is 1 plus x squared times du of x over the x, which is 8x, minus u of x, which is 4x squared, times dv of x on the x, which is 2x times 2x, all over v of x squared. V of x squared, that is 1 plus x squared, all this squared. This will simply be equal to, we have to expand the brackets. 1 times 8x gives us 8x, plus x squared times 8x gives us 8x cubed, minus 4x squared times 2x gives us 8. 4 times 2 gives 8. X squared times x gives us x cubed. all over, at the denominator, we are just going to leave it as such without expanding, over 1 plus x squared, all this squared. This will simply be equal to, at the numerator, 8x cubed minus 8x cubed, this goes to 0. We'll be left with 8x over 1 plus x squared, all this squared. The f of x on the x is the same as f prime of x. This will give us f prime of x to be equal to 8x over 1 plus x squared, all this squared. Next thing we have to do is we have to find f prime of 2, and before we take the square root. F prime of 2 will simply be equal to, in the function f prime of x, we are going to replace x with 2. Replacing x with 2, this will give us 8 times 2 all over 1 plus 2 squared, all this squared. 8 times 2 all over 1 plus 2 squared, all this squared, which will simply be equal to 8 times 2 is 16 all over 1 plus 2 squared. 2 times 2 is 4, all this squared. And this will simply be equal to 16 all over 1 plus 4 gives us 5 over 5 squared, which is simply equal to 16 all over 5 squared. 5 times 5 gives us 25. F prime of 2 is simply 16 over 25. We need the square root of f prime of 2. It will simply be equal to the square root of 16 all over 25, of which we can break this as the square root of 16 all over the square root of 25. And this will simply be equal to the square root of 16 gives us 4 all over the square root of 25, which gives us 5. We conclude, therefore, the square root of f prime of 2 is equal to 4 on 5. We are done with the solution of this question. If in case you have any worries, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.